This mini lecture will cover the topic of quadratic functions, and specifically we'll look at graphing quadratic functions. So if we first look at a quadratic function in the form of ax squared plus bx plus c form, this is known as the general form of a quadratic function, or a standard form of a quadratic function. When we have our function in this form, we can look at this a value. The a value is that leading coefficient. So if that a value is greater than 0, then that means our entire shape, which is the parabola, will be concave up. If the a value is less than 0, meaning if it's negative, then our parabola will be concave down. So if the a is positive, it's opening upward, concave up. And if it's negative, it's opening downward, it's concave down. There are a few more things we can look at to help us to graph. There's that c value at the very end, that constant. Well, that constant right there is always going to be our y-intercept. The y-intercept is where our graph, or our parabola in this case, where it crosses the y-axis. So it will be 0, c, the ordered pair 0, c. So again, this is our y-intercept, where our parabola crosses the y-axis. So if it has a y-intercept, then obviously it has an x-intercept. But maybe I shouldn't say obviously, because a parabola doesn't necessarily have to have x-intercepts, right? It doesn't have to cross the x-axis. You could have a parabola just hanging out in, let's say, the fourth quadrant and not go past the x-axis. So if they do have x-intercepts, then these will be what's known as the zeros. They're called the zeros of the equation. So the zeros of the equation are where they cross the x-axis, or when we have the equation, we find them by factoring and solving for x. Factoring and solving for x. So I'll write that down. So factoring, or maybe not necessarily factoring. We have other techniques, right, to solve a quadratic equation. So you could factor and solve for x. You could use the completing the square method and solve for x. Or you could use the quadratic formula, which will also give you the x values. And those are called the zeros of the equation. And those are also known as the x-intercepts. The x-intercepts. The next piece of information that'll help us to graph will be the vertex. So the vertex, and I'll just draw a rough sketch of a parabola. Let's say we have this parabola that's concave up. The vertex is right there where it changes direction. If we were going, let's say, on a roller coaster ride and following this parabola, we would be going downhill, and then we would hit the bottom and go back uphill. So where it changes direction, that is known as the vertex. On a parabola that's concave up, the vertex is the minimum point. On a parabola that's concave down, the vertex is the maximum point. And we can find the vertex, which we know is an ordered pair, by using the following. We can find the x value of the vertex by using negative b over 2a. Where do we get the b and the a? Well, we get the b from the value that's right in front of the x, and the a is the value in front of the x squared. So that's how we get the x for the vertex. Now how do you get the y? You get the y by inputting that value that you just got into the original function. So if we get negative b over 2a and get some value, then we're going to plug that negative b over 2a value into the original function for x, and then we'll get the y. So putting everything together that we just discussed, now we can look at our example. Let's say we were told to graph f of x is equal to x squared plus 6x minus 16. Along the way, I'm going to also determine different characteristics of this quadratic function and then graph it. So looking at this, the a value here is an invisible 1. Well, 1 is greater than 0, so I know that my sketch or my graph will be a parabola that's concave up. I know that just from looking at the a value. If it were a negative, I would know that it would be concave down. So the next thing I want to do, maybe let's figure out the x-intercepts. Alright, so to figure out the x-intercepts, I'm going to take x squared plus 6x minus 16 and set it equal to 0, because I said that earlier, the x-intercepts are the zeros, meaning the answers. So for this one, I'm probably just going to go ahead and factor this. Again, if you don't want to factor, you could use completing the square method. If you didn't want to use that, you could go ahead and use the quadratic formula, which would also give you the zeros, or the answers, the x's. Alright, so I'm going to put an x in both sets of parentheses and say what times what makes negative 16, and the same two numbers when I add or subtract will make a positive 6. I'll say a positive 8 and a negative 2. Positive 8 times negative 2 makes negative 16, and positive 8 and negative 2, when I add them, make positive 6x. So then x minus 2 equals 0, x plus 8 equals 0. And then just solving for x is equal to 2, x is equal to negative 8. So these are my x-intercepts. I can write them as an order pair as 2, 0 and negative 8, 0. The next piece of information would be my y-intercept. So if you recall from earlier in the video, the y-intercept is that c value right there, that c value. So the y-intercept is negative 16, or more specifically 0, negative 16. What else can I get from this? Probably my vertex. Let's go ahead and look at the vertex. Let's see what we said to do to find the vertex. If you look back in the video, it said to use x is equal to negative b over 2a. Well, what is the b value? The b value is a 6, and the a value we said is a 1. So you have 6 over 2, that makes a negative 3. And then I believe I said to take that negative 3, we're using f of negative 3, and we're plugging back into the original function, the x squared plus 6x minus 16. So negative 3 squared plus 6 times negative 3 minus 16. Crunching the numbers a bit, we should get 9 minus 18 minus 16. And then 9 minus 18 is a minus 9. Minus 9 and minus 16 will make minus 25. So therefore, my vertex is going to be negative 3, negative 25. So looking at all of this information, I'm going to highlight everything that I'm going to plot on the XY coordinate system. I'm going to plot the x-intercepts, the y-intercept. I'm going to plot the vertex as well. So let's go ahead. I think since the numbers are large, like 16 and 25, I'm just going to go ahead and use the origin, but count by twos. So let's say I go up 2, the next one will be 4, 8, 12, 16 will be right there. Same thing in the other direction. I'll count by twos. 2, -4, -8, -12, -16. Right? And then I'll go in the other direction by twos as well. 16. It looks like it only goes, would allow me to go up to 14 in that direction. I will go ahead and plot my x-intercepts. One is 2, 0. We said we're counting by twos. So 2, 0 is right there. And -8, 0. -8 is right there. My y-intercept is 0, -16. It's right there. That's where my parabola crosses the y-axis. Those other two were where my parabola crosses the x-axis. Next, I'll do the y-intercept. The y-intercept is at -3, so we're counting by 2, so -3 is between 2 and 4. And then -25. Well, I went down to 16. 25 will be off the coordinate system a bit, but that's okay. Probably down here somewhere. All right. And then I can just use that and connect the dots. That's my vertex, so I know that's where it changes direction. Another thing that I didn't mention was something else that is important, which is the axis of symmetry. The axis of symmetry. So the axis of symmetry is just a vertical line, and I'll make it a dotted line that cuts the parabola in half, because the parabola is a symmetrical figure or shape that you're drawing. So it cuts it right in half. So it actually cuts it in half going through the vertex. So whatever your vertex is, the line of the axis of symmetry is x is equal to whatever that x value of your vertex is, which is -3. So I should highlight that as well. That's something else that I'll do in just a moment. So first I'm gonna, let's use green, connect the dots, going down to the vertex, coming back up, on the other side. I'll make my axis of symmetry, which is x equals -3. Remember, the axis of symmetry is a vertical line, and it'll be x is equal to whatever the x value of your vertex is. So I'm just going to make it a dotted line. -3, we said, is right between 2 and 4, so it's right there. So I'm just going to make my dotted line right there, going all the way through. This dotted line in the pink is my axis of symmetry. X is equal to -3. As you recall from your algebra, when x is equal to a number, it's a vertical line. So that's my axis of symmetry line. So if the problem also asks you for a maximum or a minimum value, I told you in the beginning that if your parabola is concave up, it has a minimum value. If it is concave down, it has a maximum value. So ours has a minimum value. Our minimum value is at negative 25, right? And it has a minimum value right there because that's where it changes direction after going downhill and then increasing back up, after decreasing and then increasing. All right, and then the last two pieces of information I want to share with you are how to find the domain and also the range. Well, the domain would be all of the x values in your function. So looking at the graph, the x values, well, the arrows mean it goes on up forever to the left and up forever to the right, right? Those arrows and the lines of the parabola, they're not going straight up vertically. They're slanted still a little bit. They're still going to the right, on the right side and up, and to the left and up. So therefore, that means the x-axis is increasing in both directions, to the negative infinity and to the positive infinity. So the domain is from negative infinity to positive infinity because the lines are going on forever and ever and ever, and they're not just going straight up vertically, they're going up to the left and up to the right. So that's why the x values, the domain, are negative infinity to positive infinity. Now the range is a little bit different. The range are the y values. You read the graph from the bottom to the top. Well, it's not going on forever to the bottom, right? It's starting at that negative 25. So we have a bracket this time, negative 25. And how far up does our graph go? Well, it's going up forever. So it's going to infinity. Infinity always uses parentheses. So this is the graph of the function. We found the x-intercepts, the y-intercept, the vertex. We found the axis of symmetry. From the graph, we looked and found that it had a minimum, and we found the minimum value. We found the equation for the axis of symmetry. We found the domain, and we found the range. And then we made sure to properly graph a sketch of our function.